Hello, this is Eric Ramming. I'll be presenting my restaurant ingredient inventory system, or RIIS for short. It's a class project for 702 cloud native architecture and microservices. The RIIS system really solves the business use case where restaurant owners or managers struggle to find a Goldilocks amount of inventory to keep. You don't want to have too little inventory or you won't be able to meet your customer demands. So you'll lose sales revenue and you also lose customer loyalty. You also don't want to have too much inventory because then you will lose money if ingredients expire. You might run out of room for storage in your kitchen, and it just takes time to buy those extra ingredients. Um, so in this presentation, I'll be launching a stack to AWS, which I'll kick off now. We can see that that is going. Then I'll go through the architecture of the system. We'll briefly review the resources in the AWS stack, go through the CI/CD pipeline, and go through a quick data example. So we can see a create is in progress. Um, so we'll go into our architecture. So we're using Kubernetes in the cloud. This is a generation 2 cloud technology. Kubernetes really allows us to be elastic with our scaling of services. We're integrating that with event-based architecture. So we have three services. The first is the sales inventory manager, which is an API. It receives requests from a point of sale client anytime a sale happens and updates our inventory database and our sale database anytime a new sale comes in. When our inventory database changes, it'll send a message on the supply change queue, which is read by the supply gap analyzer. That looks at the sales history and forecasts demand for the next day. It then converts that menu demand into ingredient demand and passes that report as a message to the supply gap queue. The pricing analyzer reads from that queue and enriches the report with live pricing data from the Kroger API. And then that report is sent to an SNS topic to which my email is subscribed. Let me actually confirm that subscription now. So we'll be able to see that report when it comes in. Then a human is in the loop. This could be a restaurant employee going out and actually purchasing the ingredients. And once they've done that, they will then update the digital system with a post request to our API. All right, our stack should be created by now. And there are just two quick commands that I have to do to allow our GitHub runner to access our Kubernetes cluster. So there's the first command. Here's the second command. All right. Now we'll kick off. All right. The CI/CD pipeline does a few things. It gets some AWS credentials, uses those credentials to log into the Elastic Container Registry, and then builds three different images and pushes them to the registry. So the Sales Inventory Manager, Supply Gap Analyzer, and the Pricing Analyzer. It then configures kubectl so that it can use Helm to install our deployments into the EKS Kubernetes cluster. We'll also look at our CloudFormation template real quick. So we have the three tables. These are the DynamoDB tables, which are great for really quick lookups on a single key. We have our queues and our topics. We have policies assigned to each service, as well as our GitHub runner. And then we have roles for each of those policies, roles associated with each of those policies. We can see our GitHub runner is in the thick of it right now. So it's doing the final image, pushing the final image. So we'll come over here and we will see what's going on. All right, so it still hasn't finished, but we'll watch the pods and see them get created here. There we go. We have two of them being created. three of them being created, and that's because our runner has finished pushing everything and installing things with Helm. So they're almost ready. We're getting close here. And then this is what our template looks like. This is one example. This is the pricing analyzer of what was installed. So we have a service account, so we can assume AWS roles. We also have a deployment that specifies the image from our registry. And it also um, has environment variables that are set, including some Clover specific ones that are secrets in our Kubernetes cluster. All right, everything should be ready. So we're gonna initialize our databases with some sample data. You'll see that here, adding ingredients, we're adding recipes, and we're adding sales history. Now we can come over here, get our IP address for the load balancer, and then we can kick off a sale. You can see that we bought an Italian sub, which is listed there. You can see that reflected as well in the logs for our API, where we're subtracting the relevant ingredients from our inventory and we're saving the ID, or sorry, saving the sale for future forecasting. A message will then be sent to our supply gap analyzer, which receives it and predicts tomorrow's demand. You can see here, based off the sales history. It then uses the recipes to convert that to ingredient demand, compares it to the current ingredient inventory, and generates a report. You can see we need 5 pepperoni and 6 cheese based off the demand. And we have 25 noodles expiring. It then sends that to the pricing analyzer, which reads from its own queue and reaches out to Kroger to enrich the report using the ingredients that were included in the report. It adds the pricing data, which you can see here, and then sends it to our SNS topic. So we will analyze that quickly. Great. So you can see 5 pepperoni and 6 cheese and 25 noodles expiring, which represent a potential financial loss of $115. So there's 5 pepperoni, 6 cheese. There we can simulate an employee buying the ingredients and then using the API to update the inventory. We can see that that request came in and our inventory was upgraded successfully. And then finally, that'll kick off the whole system again, and we'll get another report. And here you see that we don't need any ingredients because we just bought everything, but we still have those 25 noodles expiring. So this was a very quick demo of the RIIS system for my cloud native architecture and microservices class. We reviewed the business need, the architecture using EKS in AWS, and we ran through a really quick data flow example. Thank you for watching.